objective 3, we're going to be stating our conclusions. So in objective 1 and 2, we learned how to state and start our hypothesis testing. And then in 10.2 and 10.3, we're going to do the middle work. We'll do the math, the calculations. And then after we do our calculations, guys, we're going to be able to make conclusions. And that's what we're doing right now. So you have to be total actors and actresses, okay? You don't know why we're making these conclusions. You do not know why they're determined to be rejected or not rejected. You will in about 20 minutes, okay? But right now you don't. So they're just saying, okay, if we do reject the null, what does that mean? And we're just going to be starting about the conclusion. So it says, once the decision to reject or not reject the null is made, the researcher must state his or her conclusion. So if you can say, oh, get rid of the null, what the heck did you find out? It's important to recognize that we never accept the null. So when you make your conclusion, guys, you'll just say, do not reject. You won't say accept. Because do they ever say innocent in court? No, what do they say? Not guilty. It's kind of the same thing. We don't have enough evidence to prove you're guilty, so according to us, it's not guilty, but we don't say innocent, okay? So we never accept the null. We just say, don't reject the null. When there is enough evidence to reject the null, we say there's sufficient evidence to support H1, okay? So this is H1 if you remember. The alternative hypothesis is H1. And the reason why I'm noting that is because I'm completely okay with you saying there's sufficient evidence to support H1. You know what I mean? Like, save yourself some writing. You don't have to write alternative hypothesis. When the null hypothesis is not rejected, a keyword not rejected, then there's not sufficient evidence to support H1. And that's what can get tricky, okay? Because we're either rejecting or not rejecting H naught to support or not support H1, okay? So, and they're back-to-back things in your hypothesis test. You'll say, do not reject H naught, and then right behind it, the next step, you'll say, there's not sufficient evidence to support H1. So let's see what's going on here with this first example, okay? And again, before we start, it says, we never say the null is true. It could be true. We never know if it is. So we just say there's not enough evidence to prove otherwise. All right, at a certain university, the mean income of parents of the entering class is reported to be $91,600. The president of another university feels that the parent's income for her entering class is greater than this. Suppose the sample evidence indicates the null is rejected or not rejected. Before we even do that, let's write our null and alternative right up here. So we know what we're rejecting and what we're not rejecting. What parameter are we going to be using? Mu, p, or sigma? Mu. Why is it mu? Because we're talking about mean, right? So the symbol for mean is mu. What calculated symbol does the null alternative or null hypothesis always have? Equals. And then remember, your alternative hypothesis always has whatever somebody's trying to claim. So if you read the last sentence, the president at another university feels like hers is greater than 91,600. So what are we going to use? Greater than. Okay? Whenever you're talking about means, make sure you have units. So since this is money, we're just going to make sure we have our dollar sign. So again, at a student university, the mean was this, but another university feels that theirs is more. Is that okay, setting those up, guys? Figuring your parameter, your symbol, and then what your number is. All right, so suppose we reject the null. If you reject the null, you're going up here. If it is rejected, you're saying there is sufficient evidence to support H1, okay? So there is sufficient evidence to support H1, right? But we know what H1 is. What's H1 saying? In words, what is this saying?
The mean income of parents entering class is greater than 91.
Right, and we don't even have to be that wordy, but that's exactly how my math is going to do it, Missy. So we can just say there is sufficient evidence to support that the mean income level is greater than $91,600, okay? There is sufficient evidence to support the mean income level, but it is of the parents of the entering freshman class, you know. Mean income level is greater than 91,600, aka H1. And I'll just put that behind there, okay? And you're like, well, how do you know that? Kind of visually, don't actually do it, but if you need to do it, you can. If you're rejecting the null, that means you're getting rid of this, right? If you're rejecting the null, that means you're getting rid of this. So what must be true? The alternative. So you have sufficient evidence to prove that, all right? Flip it around, though. Say we do all this math, and with our sample, we can't get rid of the null, okay? Meaning we can get rid of him. What do we have to say? There's not sufficient evidence to support that the mean income level is greater. All you do is write the exact same sentence, but since it's not rejected, you put the word not in front of sufficient. That's it. You can either support it or not support it, okay? So since it's not rejected, we're going to say there is not sufficient evidence to support the mean income level is greater than the 91,600. It's literally the exact same sentence, but if you can't reject the null, that means you can't get rid of him, you can't prove him, okay? This is always what we're trying to prove and disprove, okay? So we're always trying to have evidence to support him. So if we can get rid of him, we have enough evidence to support him. So that's why we can say there is sufficient evidence. But down here, if we can't get rid of him, maybe our average was only like 92,000. It was more, it just wasn't a big enough difference to say, oh, you're right, it's more than 91,000. So if there's not in the rejection, guys, there's a not in your sufficient evidence. And it's always H1. All right, what we're going to do is we're going to put it all together now without the middle part, okay? So you guys are going to be doing like 3 of the 6 steps of hypothesis testing. You're going to do the first couple, and then you're going to do the last couple. All right, so let's look at this example. It says a wizard tells a princess that the average length of a unicorn's horn is 14 inches. The princess believes the actual length is not 14 inches. First, let's determine the hypotheses. I used to have this on the test, and there's this one kid that hadn't been in class forever. So he comes out of nowhere, has no clue how to do this, and he just said, because it says, like the question is the princess right? And they're like, no, because there's wizards and unicorns don't exist. And I'm like, ha ha ha, minus 10, or what, you know what I mean? Like, he's trying to be funny, but I'm like, you still need to know how to do it. So we try to play it up a little bit just to be silly, okay? So what's the parameter we're going to use for our hypotheses here? Mu, right? Because you see that word average, correct? So we're going to have mu and mu. What symbol does the null hypothesis always have? Equals. And what we want to say is the princess, she's the one that's trying to call BS, right? So this wizard's making a claim that it is 14 inches, but the wizard or the princess is trying to call him out. What does she think the actual length is? Not equal, right? So not equal. And then remember, once you put your number there, just make sure the unit's with it. So what are we talking about? 14 inches. All right. Typically, in a hypothesis test, this would not be your next step, but it is a good review for 10.1. What was a type 1 error? That's when I'm like, okay, what was a type 1 error? That's going back to our Punnett square. A type 1 error was when we rejected the null when it was true. So I'm going to write that in like those words, but then we're going to write it according to the problem. So reject null, reject H naught when, bless you, it's true. And this is how I'm going to have you do it on the test, guys, because there is going to be one problem where we just talk about a type 1 error. We don't even worry about type 2s on the test. But we'll have one, and I'll say, okay, what are your hypotheses, and what is making a type 1 error in terms of the specific problem? So it's worth 2 points. So if you say reject the null when it's true, you're going to get 1 of the points because you know what a type 1 error is, but you didn't put it in context of the problem, right? So you go back to our problem, and our problem says the mean is 14 inches. So that means that's true. The mean is 14 inches, but what did we do? We rejected it. So to put it in words, you would just say, we would reject the null hypothesis that the average length was 14 inches when in fact it really was 14 inches. We would have, I can't even write, we would have rejected the null. We would have rejected the null that the average length was 14 inches, when in fact, it was 14 inches. We would have rejected the null that the average length was 14 inches when in fact it was. So the type 1 error is when you get rid of the null when it was really true. So say we collected data and for some reason our data was way off, like we got an average of 11 inches. We would have been like, oh, nope, I think it's something different. So I don't think it's 14. But for some reason when we sampled, we just happened to sample unicorns with short horns, okay? And that's why we got that. So really the average 14 inches, we just had a bad sample that made us reject it. All right, if you flip it to the top of page 5, guys, what we have is a type 2 error. I want to go over this because your MyMathLab doesn't split it between type A and type B. If it asks you about type A, it's asking you about type B. On the test, I won't ask you about type B because it's just the more complicated version that we can't calculate, so I'm not as worried about it. But the type B is just the flip-flop. It's when the alternative was true, but you did not reject the null, okay? So, again, put it in layman's terms if you need to. Did not reject H naught when should have. Oh, yeah, you can't see anything, sorry. Did not reject H naught when should have. Okay? So we didn't get rid of the claim that the mean was 14 inches when we should have. So again, maybe we took our sample and we got 14.4. We're like, that's pretty close, so I'm not going to get rid of the null. But again, it's due to sampling, and we're actually closer to 16 in the population, okay? So you did not reject H naught when you should have. So what is that in terms of the problem? We would fail to reject the claim the average length is 14 inches when in fact it is not. If that couldn't be more confusing. We would fail to reject the claim that the average length is 14 inches. So we would say, not guilty, when in fact they were guilty, okay? We would fail to reject the claim the average length is 14 inches when in fact it is not. Again, C, I wouldn't worry as much because we're not going to do it in 10.2 or 10.3. It's basically in order to ask you about type A problems on MyMathLab, type B follows them. There's no way to differentiate between those two problems. All right, D and E are where you guys are going to be little actors and actresses, okay? So this claim was made by the wizard that the average length was 14 inches, and the princess is like, you know what, I don't think it is. So what does she do? She goes and collects data and measures a bunch of unicorn horns. And she collects this data, she does her math, beeper bopper beep, which you're going to learn how to do in about 10 minutes, and she's able to reject the null. She's able to reject the null. What's your conclusion? Guys, your conclusion is always the same. There is or there is not sufficient evidence to support H1. So if we're rejecting the null, what can we get rid of? Him, and who can we support? H1. So we would say there is sufficient evidence. Let me bullet down so you can see it. There is sufficient evidence to support, and I'm going to let you just write H1, okay? I'm a little bit more lenient on this than some instructors because I feel that if you wrote what H1 was in step A, then why rewrite all of it? You know what I mean? So basically in words, there is sufficient evidence to support the claim that the mean is not 14 inches. And you can write it that way if you want. But you just wrote what H1 was right there, so I don't see a point in you writing it again, okay? So there is sufficient evidence to support H1 that the claim that the princess made was that it's not. So basically the princess was right. She was able to go collect data and say, wizard, stop saying that lie. I was able to prove otherwise, okay? All right, now scratch that from your memory. Say the princess went out and she recorded all these unicorn links and got an average that wasn't far enough away from 14. So maybe it was 14.2. And she's not able to reject the null. And she's not able to reject the null. What is the conclusion then? The exact same sentence, but you just say there is not sufficient evidence to support H1. There is not sufficient evidence to support H1. Meaning, does that mean the average length is 14 inches? No, we can never say that's true. We can never accept it. We can just say there's not enough evidence to prove otherwise. So the wizard can keep making his claim until we can gather enough unicorn links to prove otherwise.